Hi, everybody. It's Professor Mitchell. We're starting a new chapter today, chapter 3 on graphing. First section is 3.1, reading graphs and the rectangular coordinate system. In this section, we will actually skip reading bar and line graphs. I have never included this objective in the lecture, and students have been able to do it in the homework. So we will actually start with defining the rectangular coordinate system and plotting ordered pairs of numbers. We will graph paired data to create a scatter diagram. Actually, I'm not going to do that either. Determine whether an ordered pair is a solution of an equation in two variables. And finally, we will find the missing coordinate of an ordered pair solution given one coordinate of the pair. The student learning outcome throughout, I think, all of this chapter is to construct graphs of linear functions. All of those other things will come later. All right, so we start a new chapter, as we often do, with some vocabulary. When we talk about an ordered pair, we're talking about two numbers associated with a point on a graph. The first number gives the horizontal location of the point. The second gives the vertical location. A coordinate is a number in an ordered pair. We usually have an x coordinate and a y coordinate. The x-axis is a horizontal number line. You see it here in this graph. The y-axis is a vertical number line. That's this line here. The origin is the point of intersection of the two axes. That's this point right here in the center. And then finally, the quadrants are the four regions created by the intersection of the two axes. Up on the top right, you have quadrant 1, and then you continue counterclockwise. Top left is quadrant 2, bottom left is quadrant 3, bottom right is quadrant 4. So our first example is going to be to plot each ordered pair and then to state in which quadrant or on which axis each point lies. So that's something I should mention. When a point lies on one of the axes, we say that it does not belong to any of the four quadrants. Switching over to the tablet. All right, so the first point is 2, 4. So before we get into this, let me just mention you have an X and a Y. As I mentioned earlier, the first coordinate tells you which way to move horizontally. So if that number is positive, you move to the right. If it's negative, you move to the left. And then the second number tells you whether to move up or down and by how far. Positive means up, negative means down. All right, so 2, 4 means 2 to the right and 4 up, because both of those numbers are positive. So that is going to put us right here, 2, 4. 2, 4 is in quadrant 1. All right, next we have negative 2, 1, because that negative 2 is negative. That means move to the left. And I should mention we're always starting at the origin. So we go 1, 2 to the left and then 1 up. There's the point negative 2, 1. It is in quadrant 2. All right, next we have 3 and 3/4, 0. So that's saying to move 3 and 3/4 to the right. So I'm going to go 1, 2, 3, and then you can imagine cutting this segment between 3 and 4 into quarters. 3 and 3/4 would be right here. Notice the y coordinate is 0, so I'm not moving up or down. 3 and 3/4, 0 is not in any quadrant. It is on the x-axis. All right, and then finally we have 1/3, 5. So again, I'll cut the segment between 0 and 1 into thirds. So 1/3 is right about here. Oh, I was afraid this might happen. I'm going to end up in the space where I was writing. So that's going to be right here. And I'll just make a little arrow. Okay, and that point is just barely in quadrant 1, right? Okay, so hopefully that seems easy. It really is. Okay, back to the presentation. Yep, I thought I skipped one. Okay, so next we will determine whether each of these ordered pairs is a solution of the given linear equation. So I'm going to go back to the tablet and show you how we do that. So we say that an ordered pair is a solution of a linear equation if it makes the equation true. And remember, the first number has to go in for x, the second number has to go in for y. So starting with 2, 3, I'm going to write 3 blank plus blank equals 8. And then I'll put a 2 here and a 3 here and put a question mark there. 3 times 2 is 6. 6 plus 3 is not 8, it is 9. So this ordered pair is not a solution. The next one is 0, 8. So we'll do the same thing. 3 blank plus blank equals 8. Put a 0 for x and an 8 for y and a question mark here. 3 times 0 is 0. 0 plus 8 is 8. So that one is a yes. All right, and then finally, we have 8, 0. 3 blank plus blank equals 8. This time I'm putting in 8 for x and 0 for y. And I think you can see where this is going. 3 times 8 is 24. 24 plus 0 is not 8. So that is a no. What I like about this example is it emphasizes the ordered in ordered pair. 0, 8 was a solution. 8, 0 is not a solution. So the order definitely matters. All right. Next, we're going to complete the table of ordered pairs for the linear equation. And I think, yes, this is going to be the last example. So going back to the tablet. This is a little different from what we just did. So what I'm going to do here is substitute 0 for x for the first one, and then solve for y. Okay. So there are 3 parts to this problem. We're finding a total of 3 ordered pairs, starting with when x equals 0. We have 0 minus 6y equals 3, which means negative 6y equals 3. Dividing both sides by negative 6, you get y equals negative 3/6, which simplifies to negative 1/2. So that completes that ordered pair. The ordered pair 0, negative 1/2 would be a solution to this linear equation. Next, we have x equals 1. So we'll do the same kind of thing. This time it's 1 minus 6y equals 3. So this time I have to start by subtracting 1 on both sides, which gives me negative 6y equals 2. Dividing both sides by negative 6, you get y equals negative 2, 6, which simplifies to negative 1/3. And finally, notice that the third ordered pair has a y coordinate of negative 1. So I have to be careful there, and I think I can squeeze it in down here. Y equals negative 1. So this time we're going to go x minus 6 times negative 1 equals 3. Minus 6 times negative 1 gives me a plus 6. And then subtracting 6 on both sides, I end up with x equals negative 3. All right, and that's all there is to do in this section. I believe in the next section, we're going to start graphing linear equations using these ordered pair solutions. So we will see you for that next time.